Okay, Jordan, we're going to do logs real quick. These here are the rules, okay? Um, you probably already done that real quick, but you've done a lot of it already, but I'll go ahead and um, show you some of the basics again. Hopefully I can make this video a little more concise. Already 25 seconds in. Basic rule. You have a log base 3 of 5 or something like that. That we'll look at this rule here. So that's saying a log base b of x. Well, we have the same thing, log base 3 of 5. That's saying it can be expressed as the log with any base. We'll pick 10 over the log of any base of the top. So we'll give you a second to think. You can pause if you want. So this is equal to the log base 10. So I'm not going to write the 10 here. So you just remember it's 10. It's the log of 5 over the log of 3. Okay, log base 10 of 3. So this is the same. You could express it this way. Again, right here or over on the left, if you look over here, it says any base. So you could also express this as the natural log of 5 over the natural log of 3. It doesn't matter. Any log where you have a base and a argument, you can express divided like that. Okay, so that's pretty easy, I think. So that's the first rule. Second, we need to look at logs in general, what they are, what they're useful for, I guess. If you have a to the x equals y, and you want to express this as a logarithm, it's the log base a of y is equal to x. You see it kind of goes in a circle there. So again, the log base a of y is equal to x. And if you look at it, it kind of, if you kind of filter on the log there, it's almost a to the y equals x, but anyway, you see the difference. And so that's a real quick way to switch these around. That's a real quick way to solve for x. So that's a relationship. What we were doing earlier, I think you've done this already, is you see, well, I want to solve for x, and it's in that exponent. So I just take the log base a of both sides, and I'll write this real small, and take the log base a of both sides, and that negates this, and it just becomes x equals the log base a of y. Okay, just another rule we can cover right here. Why does it work? If you have an exponent, so if you look over to the left, rule number 3, if you have an exponent, you can pull it out. So you can pull that n out in front. So log base b of x to the n is equal to n times the log base b of x. See that n that was there, the n that was there, we pulled out in the front. Okay, so that's kind of what we're doing here when we do the log base a of a to the x. We pull the x out in front, so x is in front, and then it's x times the log base a of a equals the log base a of y, and then log base a of a is 1, and then that's it. That's kind of how we simplify that. All right, so there are a few other rules. I'll just do them really quickly. There's the multiplication, log base b of x, y. If you have two arguments multiplying, it can be expressed like this. And I'll drop the b for now. You know how to deal with that. So it can be expressed as the log of x plus the log of y. Okay, and then if you have the log of x over y, that can be expressed as the log of the numerator minus the log of the denominator. Okay, so we'll take that a bit further. What if you combine these? What if you do the log of xy over b, and we'll assume these are all variables. Actually, it doesn't matter, but these are all variables. You can do the same thing again. So okay, numerator, denominator. We go back up here. Well, there is no numerator, denominator. Anytime here you want to multiply, or anytime here you see multiplication, you just express as a log of the first term being multiplied plus the log of the second term being multiplied. Anytime you have a division like this, it's the log of the numerator divided by the log of the or minus the log of the denominator. Okay, so here we have a numerator and a denominator. So to start out, we'll say, well, it's the log. It'll be the log of the numerator times, or I'm sorry, minus the log of the denominator. Okay, that b. All right. So that's half of it, and then we just need to expand this further because we have this multiplication rule up there. And since I like changing colors, again we have x times y, and we know when they're multiplying we can expand them like this. So the log x plus the log y, right? Because if it's multiplying, you add, and then you just have to do a lot of these and get some practice. So, and that's equal to the log, or minus the log of b. So that is how we would expand this original equation. Okay, same thing, we're just presenting them a different way, and it really helps when we're solving for a variable. Okay, so we're at 400 seconds, probably have about 2 minutes left. So let me do a quick review of this. AB squared over C. Okay, CB. Okay, this, when you're doing these problems, it'll be helpful to remember how to handle these exponents. Remember, if it's a B or a C or an A and there's nothing in the exponent, that means it's just a 1. Okay, and so if you wanted to simplify this, you would subtract exponent. So we have a b on the top and a b on the bottom. So the a's won't disappear, a and c, because they're not on both sides. They're not both in the numerator and the denominator. But for the b's, we have a 2 on top and the 1 on the bottom. So the rule when you're dividing is you multiply or you subtract exponents. So it's b to the second over b to the 1, and we subtract exponents. 2 minus 1 is 1, and since it's positive 1, it's b on the top. Oh man, I want to do a whole bunch of these. Alright, anyway, I'm going to do the big one real quick, and then you may have to pause as we go through it. Log ABC squared over C squared. Okay, something big like that. Alright, do the log of the numerator. I'm not going to be fast. A log B 2 log C. Notice I pulled that 2 out in the front. Oh, there's a C on the bottom. Holy crap. This is bad. Okay. Okay. There's C squared over C squared. Those cancel out. I'm done. I'm done. Maybe we can trim this. Alright, we'll do it one more time. We'll do it live! We'll do it live! Okay. How about the log of, these are all variables, A, B, c squared over c cubed. Let's do something like that. And let's do dc cubed or something like that. Okay? Alright, numerator. Numerator will expand. Oh, first of all, we want to simplify. Simplify with c squared over c cubed. C squared over c cubed. You gotta multiply, or you gotta subtract the exponents. So c squared over c cubed. 2 c's cross out on the top. That leaves 1 on the bottom. And since the 2 c's cross out on the top, this is equal to c to the 0, which is 1 over c to the 1. So 1 over c. Okay? So that goes back in here, and we're left with ab over dc. Okay. Alright, so that's that. And then we just use our rules. We'll do it one at a time. We'll start with the division. So the log of the numerator minus the log of the denominator. And then we'll expand these because we'll do the multiplication. So multiplication is the log of a plus the log of b. And you want to be careful here. Put that in parentheses. Minus the log of d plus the log of c. Okay? And then we'll put that in parentheses as well. And the reason we do that is because we'll have to multiply that minus sign through. Alright? And that's it. I'll have to trim this.